Okay, so there's this new AI model from a company called Mistral that's really shaking things up. It's called Mixtral, and it presents this fascinating puzzle. See, on one hand, it's packing a massive 47 billion parameters, and in the AI world, that's usually a shorthand for how big and powerful a model can be. But here's the catch. When it's actually running what we call inference, it only uses about 13 billion of those parameters at any given time. This makes it way faster and cheaper to run than other models it actually outperforms. So it's bigger and smaller at the same time. How on earth does that work? Well, the secret sauce is in this really clever architecture called a Sparse Mixture of Experts, or SMoE for short. So let's dive in and break down exactly how this thing works and why it is such a huge deal. All right, so here's our game plan. First, we're going to unpack that mixture of experts trick. Then we'll put Mixtral head-to-head with giants like Llama 2 and GPT-3.5. After that, we'll get into some of its other superpowers beyond the basic tests. And finally, we'll talk about why this model really matters for the future of AI. So, how does Mixtral pull off this magic trick of being both big and small? Well, the magic is all right there in the name. At its heart, a sparse mixture of experts model is built on a really simple but powerful idea. Instead of having one giant brain that tries to know everything about everything, you build a collection of smaller, specialized networks. We call these experts. And for any task you give it, the model only wakes up the few experts that are best suited for that specific job. Think of it like this. Instead of hiring one generalist doctor to handle every possible medical issue, you've got a team of 8 different specialists, a cardiologist, a neurologist, a dermatologist, and so on. Now, when a patient comes in, a smart triage nurse, or in our case, a router, figures out what's wrong and sends them to the 2 most relevant specialists. The model gets the benefit of all that deep, specialized knowledge, but you don't need every single doctor working on every single case. It's just smarter. So here's how that journey looks step by step. A little piece of information, what we call a token, comes into a layer of the model. That router network instantly looks at it and says, okay, for this token, I need expert number 3 and expert number 7. The token is then processed only by those 2 experts, while the other 6 do nothing. Finally, their 2 separate outputs are blended together to create the final result for that layer. This whole process happens super fast for every single token at every layer of the model. Okay, so that all sounds fantastic on paper, right? But the real question is, does it actually work in practice? Let's look at the numbers and see how Mixtral really stacks up against the competition. The first thing you have to see is just how efficient this is. A model like Llama 2's 70B has to fire up all 70 billion of its parameters for every single token it processes. It's all or nothing. Mixtral, with its smart router system, only uses 13 billion active parameters. That is more than 5 times less computation. That's a massive difference in speed and cost. And here's the real kicker. That incredible efficiency doesn't come with a performance hit. Just look at these charts. Mixtral, that's the yellow bar, is consistently matching or even beating the much larger Llama 2 70B model in dark green. It does this across a whole range of common sense and knowledge tasks. But when you look at things like math and code, well, it's not even a fair fight. Mixtral is just way better. And this isn't just about outperforming other open source models. Look what happens when you put it next to a closed source giant like OpenAI's GPT-3.5. On general knowledge, they're pretty much neck and neck. But when it comes to code generation and mathematical reasoning, Mixtral actually pulls ahead. It's delivering truly top-tier performance, but with a design that's just fundamentally more efficient. But, raw benchmark scores only tell part of the story. Mixtral has a few other superpowers up its sleeve that make it even more impressive in the real world. Okay, so this is really cool. This isn't some synthetic test. This is the LM-SIS chatbot arena, where thousands of real people vote on which AI they prefer in blind head-to-head matchups. And look at this. Mixtral's instruction-tuned version isn't just the best open source model, it's actually ranking above famous models like GPT-3.5 Turbo and Claude 2.1. That means people genuinely prefer talking to it. It's a world-class conversational AI. Another one of its big wins? It's a true polyglot. The team behind Mixtral was very deliberate about training it on a ton of multilingual data, and it absolutely shows. As you can see here, it scores exceptionally well in languages like French, German, and Spanish, leaving models like Llama 2 in the dust. This makes it a far more useful tool for global applications. And finally, let's talk about memory, because this is just incredible. This chart shows the results of what's called a needle in a haystack test. The idea is simple. You hide a tiny, unique piece of information, a passkey, somewhere inside a huge document, up to 32,000 tokens long. Then you ask the model to find it. Mixtral found it with 100% accuracy, every single time, no matter how long the document was or where you hid the needle. That is a flawless demonstration of a rock-solid, reliable long-term memory. So, let's pull back for a second. We have a model that's powerful, incredibly efficient, and versatile. What does this all mean for the bigger picture of AI development? If you take away nothing else, remember these three things. 1. Elite performance. Mixtral proves you don't need a 100 billion parameter behemoth to compete at the very top. 2. Radical efficiency. This mixture of experts approach is a total game changer for cutting costs and boosting speed. And 3, maybe the most important point of all, open source access. Mixtral was released under the very permissive Apache 2.0 license, which means anyone from students to researchers to startups can grab it and build on top of it for free. And that combination, that blend of top-tier power with truly open accessibility, is just a massive catalyst for innovation. It dramatically lowers the barrier to entry for building world-class AI. And that leaves us with a really exciting question to think about. Now that this level of technology is in the hands of the many instead of just the few, what amazing new breakthroughs are just around the corner?